Hi, this is Keith Cutter with EMFRemedy.com. Our guest today is Rob Metzinger. Rob is the president and founder of Safe Living Technologies Incorporated. We're about 2 weeks from market availability of Safe Living's latest product called the Safe and Sound Pro mmWave, which is mmWave meter, which is the subject of our discussion today. Rob is an electronics engineering technologist, a building biology environmental consultant, and an electromagnetic radiation specialist. Rob, welcome.
Thank you, Keith. Thanks for having me. Great to be here.
I understand you have a presentation for us, and we'll get into that in just a minute. But I just want to remark that you guys are on a real roll with regard to new product introductions. You guys have the Classic, and then the Safe and Sound, and the Safe and Sound Pro 2, and the Micro, and it's been a lot of product introductions in a short period of time, and you're not done. You've got one after this, don't you?
That's right. Yes. No, thanks for that. And we've had a busy few years, and our ideas are to get these out as quick as possible, but they never seem quick enough for us. It seems like it's a long process developing each one of these products, just because we want it to meet building biology guidelines for one thing, and we also, want it to be reliable and a good product. So takes time for that, but we've managed to get them out, as you said, and we're very, very proud of the products we have out there, and then the products coming as well. And part of that presentation that's following this will involve a little bit of an explanation about the mmWave meter, as well as the new EM3 electric and magnetic field and body voltage meter we have coming out, a 3-in-1 meter. So those are the two that we're currently working on, and the release of the mmWave meter will be an exciting time for us. The amount of work we've done on the mmWave, I'd say, is double or triple any other meter we've done. Just because of the technicalities of the 24 to 40 gigahertz. It's a different animal to deal with. So that's all I'll say about that. It's been a challenge.
It's been a real moving target as well, with the 5G standards not really clear up front and evolving, right?
True, it's a learning experience, and once this meter is out, and we do have it in beta testers' hands right now. Just like you have one as well, Keith. We're learning more and more every day from from the testers, and we're in learning mode right now, just understanding what's out there. I think we're going to find a few surprises that we didn't expect, and I think you've got a story or two on that as well. We'll get to. Sounds good.
So great. Let's go ahead and get started with the presentation.
Okay, sounds good. I will share my screen here. And just run through this. It's about 10 or 15 slides we'll go through, and just introducing the mmWave meter, as well as the electric and magnetic field EM3 meter as well. So Keith, thank you for the introduction, and I'll just get this presentation going. So yes, Keith mentioned my credentials, so there they are again, and we're at safelivingtechnologies.com, slt.co as well. I thank Keith for having me again, and what we just put together is a brief introductory video on some of the features with the mmWave meter. We're going to start with that, and I'll just play this off of YouTube or our website here, whichever comes up when I click the button.
The new Safe and Sound Pro mmWave meter is the first consumer-level 5G mmWave meter. This meter measures high-band 5G signals between 24 to 40 gigahertz and comes with multiple accessory options for more detailed readings. These options include a horn antenna, a stub antenna, and an attenuator for various uses. To start the unit, press and hold the power button. After that, your battery level will appear on the screen. The Mode and Max Reset button will allow you to capture your maximum values of RF exposure. Now you can attach your desired antenna. To start, we will be using the stub antenna. The stub antenna is ideal for most uses. It has about 50 degrees of coverage in the front and back. It is suggested to slowly move the meter around in a figure-8 motion while in use. The horn antenna is great for more directional measurements. It has about 35 degrees of coverage in the front. Finally, the attenuator is ideal for when your RF readings are maxing out the device. If this happens and the attenuator is not installed, the meter will display a brief message and automatically shut off. When the attenuator is attached, it will display the readings as 100 times weaker, so you are able to measure at higher power levels. When measuring RF sources using the attenuator, ensure you multiply the value by 100 to attain the correct reading. Overall, the Safe and Sound Pro mmWave meter is the perfect partner to the Safe and Sound Pro 2, our low and mid-band 5G meter. For more information on the new Safe and Sound Pro mmWave meter, the Safe and Sound Pro 2, and other EMF mitigation products, please visit our website at www.safelivingtechnologies.com.
Okay, so that gives you a general overview of the meter itself, what it displays, and the various antennas and accessories we have. So getting into it a little bit deeper, just a little bit of a background of the development on this meter in particular. So we've been on this for about 8 months, and we're expected to release it on June 30th as the retail version. We do have beta testers out there now, which are valuable to us, and I'd like to thank them for assisting in the development of this meter as well, giving us feedback, and also trying to hunt for sources. Like a lot of these things are things we don't expect to find, but there's probably going to be more transmitters out there than we think. So we're in learning mode with this. So the development has been long and hard, but it's worth it. Getting a stable response required additional research and development to get down to the building biology specifications. So we were able to get down to, about the 100 microwatt per square meter, 70 microwatt per square meter several months ago. But for the building biology guidelines, we wanted to get down below 1 microwatt per square meter. And with the horn antenna, we're able to do that. So these were the challenges we faced, and trying to decide on whether or not to take it to the next level and to do that. So doing that required R&D and extra time. So that's all part of it. And we didn't want to compromise specifications or pricing, getting stuck with a higher cost item in the meter that we needed to. So, cost was a big part of this meter too. We wanted to make it affordable because there's nothing on the market that currently is affordable and as precise at this point in time. So also, anytime you're dealing with millimeter waves, the power that a meter uses or the power in transmitting a millimeter wave meter or wave works, it takes probably 4 or 5 times as much power as a lower frequency RF signal. So measuring them and having your battery life more than a few hours is very difficult to do, like you're going to see with other manufacturers. But we're proud to say we've got about 6 hours of battery life on our meter, which is excellent. And the horn antenna is another challenge as well too. In order to get the sensitivity down to less than 1 microwatt, we had to develop our own horn antenna, which is very challenging and very costly as well. So that was one of our challenges too. And that related basically to this sensitivity requirement of less than 1 microwatt per square meter for building biology guidelines. So it's challenging, and we know other companies that have been through this. They've spent months on it and years on it actually, and had difficulties with it. And I can understand why. It was very challenging and difficult to do this. And plus, getting into this, the parts are super expensive. They're hard to source at this point in time. Just after COVID, it's more difficult to get electronic components. And we also found the testing at third-party facilities. Once we have a prototype, we need to take it to a test environment and test it completely, scan all the frequencies, make sure it responds properly. But we didn't really find they had adequate equipment for our test needs. hard to believe, but a lot of companies are still stuck at this 18 gigahertz upper level. They haven't taken it to the 40 gig level yet at this point. So so we had to do that, and they didn't have a really good testing methodology for the meter as well too. So we had to do this on our own basically. So we purchased our own signal generators and power meters, spectrum analyzers up to 40 gigahertz. And we also constructed our own full anechoic chamber. So we can test, 700 megahertz to infinity, basically. It's shielded, ceilings, walls, and floors. Like a lot of testing chambers out there in the industry, they don't shield their floor. It's a ground plane, and it can be reflective. But in this case, we've shielded everything here. So we are pretty certain we're getting a true reading when we're doing our measurements here. So this is something we're really proud of too, this testing chamber. So a little bit about the meters themselves. So the frequency range is 2.24 to 40 gigahertz. So it's a high band RF millimeter wave meter. And in the US, basically we have coverage for 28 and 39 gigahertz of the 5G high band, and it's live in major cities, primarily Verizon. There's AT&T, T-Mobile, and Dish as well too that are part of it. And in Canada, we're looking at 26 gig, 28 gig, and 38 gig. So it was important for us to cover both of these bands, the one around 26, 28 gig, and also the higher one about 38 and 39 gig. So Canada still is not really 5G high band active. The spectrum auction is planned for 2024. So we're expecting more to happen in the future. But as we're finding, we're finding test sites out there as well that we're getting signals from. So we're still trying to make heads or tails of that to see what that is. But these signals are out there and they're present at this time. So we just need to hunt for them and try and understand them a little bit better, because there's a little bit of a mystery behind this whole 5G deployment. So they're called millimeter wave meters because their wavelengths are under 1 centimeter. The industry calls this service, the ultra wide band, UW you'll see on your phone, or 5G plus you could see on your phone. So that's kind of what you would expect if you're local to a high band 5G tower. Your phone will display one of these, and when you make a call, it will probably connect on that service, and that should be measurable with this meter as well. So the base model is 849, comes with the standard stub antenna and the release date of June 30th. There's other accessories, but you can check out our website for those. Basically the horn and the attenuator, the additional accessories that will go on there. I'll explain how those work in the next few slides here. So basically it detects and measures 5G in the high band millimeter wave band, 24 gig to 40 gig. And the common sources here are high band cell towers, high band cell phones, as well as some radar and some other high band 5G devices. And we're also finding automobile collision systems, the adaptive cruise control, and the blind spot recognition. They could possibly be radar signals coming out of there within this band as well. Originally, we thought they were higher band, 70 to 80 gigahertz, but people are reporting back they're finding it in this band as well. So very, very interesting news, new news to me as well. And we're also finding they're penetrating glass. Also, we didn't think they'd penetrate glass very easily, but we're getting readings inside cars as we're driving around too. So, so it's built in North America as well, and we've designed it as almost a prosumer type of meter, but it is consumer level. Anybody can use it. It's a very simple device to use, very accurate and affordable. It's a fraction of the cost of current high band detectors, where you're looking at, $15,000 to $40,000, something in that range, which is just unattainable for most of us. So it's a perfect companion to the Safe and Sound Pro 2 lower frequency RF meter. And it's very similar in operation. It displays in microwatts per square meter. We have peak and average readings, and that offers direct comparison to our building biology guidelines, which are important to us. Also has a peak hold feature, sampling rate of about 5 microseconds, and the battery life has about 6 hours with sound on. So very very reasonable with that. And it also has an audio feature, has 3 sound levels, and each source in this range also has a unique sound and a unique pulsing sound. And our idea is to get those recorded from our testers, and we'll have them posted on our website as soon as we get them, as soon as possible, so that when you're using the meter, you'll have some background on the sounds that are already out there, and hopefully we can try and identify those for you as well. Some more meter specifications. This is just like our Classic and Pro. It has LEDs that go green, yellow, orange, and red, and they correspond to the numbers over here. So for a quick and dirty evaluation, you can just look at the LEDs to see if you're in the green or if you're in the red, to know whether or not you're in the line of sight or in the range of 5G signals. So let's talk about the stub antenna. So it's kind of a quasi omnidirectional antenna. And I'll show you the directional pattern in the next few slides. But frequency response, we're looking at plus or minus 6 dB, 24 to 40 gig. It's actually, I think we're going to be able to get down to 18 or 20 gig with this as well too. We're getting extra response that we didn't plan on. So that's to come. And the minimum measurable signal is all the way down to 5 microwatts with this standard antenna, which is fairly reasonable, we think. The horn will get you down a little further, down to 0.5, but this is fairly reasonable. And the maximum measurable signal is 500,000 microwatts per square meter. Or if you stick the attenuator on, we get up to 50 million microwatts per square meter with that attenuator. And that attenuator would just insert underneath the current antenna. It would attach to the meter and the antenna, the stub antenna, and that's where the attenuator would go, right in between here. And we've got some pictures of that later. So the reception pattern is quasi omnidirectional. It picks up about 50 degrees from the front, 50 degrees from the back, and the best reception. This antenna has an SLT logo on it, and it's best if it's facing you. So we want the blank side going out towards the source and the SLT sticker side facing you. It'll make a little bit of a difference on the measurements if you have it the other way, but this is the preferred way. Then we get to the horn antenna, which is a directional antenna, and also frequency response, plus or minus 6 dB, 24 to 40. We're not seeing a lot of extra with this. If we would see it above 40 gigahertz, but the problem is getting measuring equipment to test it. So it may stretch out a little bit above 40, but we're only testing to 40 at this point. So the minimum measurable signal is down to 0.5 microwatts per square meter. And the maximum signal you can measure is about 30,000, or with the attenuator, that would take it up to 3 million microwatts per square meter. So 35-degree pattern on the front, so it is very directional. You need to really hone in and zoom in on your source to find it. And that's the purpose of it, basically, to help identify where sources are coming from. So this antenna, we've designed our own antennas. We bought industry manufactured ones, and the price is just ridiculous. So we ended up designing our own, and actually electroplated it for conductivity and reflectivity. And it works almost as well, or probably what the guys are telling me, just as well as the calibrated ones we have to do our certification testing. So we're very impressed with those horn antennas we've developed. So here's an example of the signal reception pattern. So with the horn antenna, there's a 35-degree beam out the front and basically nothing left to right. So it will really pinpoint sources for you. With the stub, we've got a 50-degree beam width, front and back, left and right, up and down. So that kind of looks like this, going out the front, going out the back. There's a little bit of less of a response in the side edges, but they do have some side lobes that do pick up something in this range. But in order to get around that, you would just twist the meter left and right, and that would allow you to pick up these signals. You know, typically we have a figure-8 pattern that we like to do in building biology, that you know, we scan a sleeping area or surface for a certain period of time and look at the peak hold reading. And that's basically what this antenna is for. So gives you the total body exposure over a period of time using the peak hold feature with that. And it will yield higher readings than the horn because it's receiving signals from multi directions as opposed to just one direction on the front. So just be aware of that as well. And then we have the attenuator. It's a minus 20 dB attenuator or 100 times signal reducer. And the frequency response is, we'll probably lose maybe a half a dB or 1 dB when we insert this, but it performs well, 24 to 40 gig. And it basically gets inserted here where the, just between the meter and the horn, as we talked about before. And any reading on this meter then, since it reduces a signal 100 times, you need to multiply the reading displayed on the meter by 100 to get the appropriate reading. So this allows the meter to display power densities 100 times stronger than what the meter would do alone. So we weren't sure what type of signal strength we were dealing with here. Once we got it out in the field, what we're finding is almost the attenuator is almost not necessary because a lot of the signals are much lower than what we've experienced with 4G LTE signals. Keith may be able to confirm that with his measurements later as well too. And so with the attenuator, we're getting up to 50 million microwatts with the stub and 3 million microwatts with the directional horn antenna. So it's compatible with both and works well. So one thing when measuring high power levels too, all FR equipment is susceptible to power overload. So we built in power overload protection to this. The Safe and Sound Pro lower frequency meter does not have this issue, but this meter does. And most of the RF meters will have to have some type of built-in protection to protect themselves from higher consistent, higher or continuous high level RF signals. So it can be damaging to the meter, and overload protection is activated when it detects this. And the following levels are the point where it's activated. So if the stub goes over 500,000 microwatts per square meter sustained for like 3 seconds or more, it will go into this max power reach level. And then the horn antenna over 30,000 sustained for over 3 seconds. And the meter will power down after about 3 seconds. And the warning message will come up to actually install your attenuator. So pretty foolproof and something that was necessary to add to the meter. So yeah, when you're measuring higher power density levels, just install the attenuator to help you with that. And so what do you see on the meter? So on startup, apologies for the blurry picture, self-calibration will come up. It'll show battery life, and you can continually run this also if you're powered into, if you use this USB port here to plug into. You can plug it into a USB-C port and a USB power adapter and continually run this meter 24/7, weeks at a time if you like with that connector. There's also a headphone connector here as well too. This button does the speaker, selects your different volume levels, as well as powers on the unit. And this is the mode button. It'll help you select which antenna to use, as well as a max reset button on here for to max reset your peak readings. So the next screen that will come up is select your antenna type via the mode switch, which is right down here. And basically you would just press the mode button once and release it. And this arrow will toggle up and down to either the stub antenna or the horn antenna. And then what you would do is you would press the mode button again for 3 seconds just to select the and set the desired antenna you're using. So pretty simple to set up, and that's the intermediate screen that will come up before you can use the meter. And the next screen that will come up is your actual measurement screen. So we're looking at peak, max, and average measurements for that. Again, there we have the headphone jack, speaker sound with 3 levels, USB, and mode and max reset buttons here. So that's basically what you're going to see. And you're also going to see an indication of RF power density as this scrolling bar across here. Right now we're at such a low level, 0.5 microwatts. That's the That's the noise floor. That's the low end of the meter for measurements. So there's no scrolling of this intensity bar on the top line here. So you'll see that more once you're measuring sources. Future meter ideas. Looking at combining maybe our Safe and Sound Pro 2 with this meter as well to have an all-in-one and a switchable unit between low frequency RF and higher frequency RF. Also looking at developing a meter from 8 gigahertz to 24 gigahertz just to fill that void. Nothing affordable seems to be in that range either. And then plus the 40 to 60 as well would be nice to have. That's there's going to be a higher band of Wi-Fi in the 60 gigahertz range, which would be nice to assess. And then we have car radar, typically around 75 gig, but we're finding different a little bit. It's popping up 24 to 42, but also having a meter that measures 60 to 90 gigahertz would be helpful as well. So that pretty well sums up the millimeter wave section, and hopefully that triggers some questions for Keith. And I'll just have a couple slides here with the Safe and Sound EMF meter, the EM3. So its frequency range, it's going to measure electric fields, magnetic fields, and body voltage. Frequency range goes from about 16 hertz all the way up to between 100 and 150, somewhere in that area. We're just evaluating and testing that out. The release date for this meter is probably going to be in September this year. So we're still sorting out, trying to pump this frequency up as high as we can. And so yeah, what the meter does, it's a 3-in-1 low frequency meter, AC electric fields, AC magnetic fields, and body voltage. Developed and made in North America, and it's going to be a professional level meter. So very, very high end, very sensitive meter. It'll be third-party certified. We will certify it in our own lab first, and we're looking at plus or minus 5 dB or better. Final testing is required for that, just to hone in on the exact number, but perfect companion for the Safe and Sound Pro 2. It may be more cost effective for the NFA 1000 if you're a building biologist and you just can't pull the trigger on an NFA 1000. This may be the meter you're looking for then. It will be a very reliable and accurate meter as well. OLED digital display, just like our Safe and Sound Pro RF meters. It'll be powered by battery or USB for continuous monitoring, just like our other pieces of equipment, the Safe and Sound line. And the common sources it'll measure is AC power lines, home electrical, and appliances, anything that consumes AC power, basically. So we got 3-axis mag field meter, 1-axis electric field meter, and body voltage meter, which is more or less a 3-axis meter as well. It uses your body, and the hand probe has the antenna, which attracts AC electric fields from all sides. And we're looking at around a 600 US, 599 US date, and or US cost, sorry, and August or September 23rd for 2023 for the release date. So still in development, but it's coming along nicely. So frequency ranges that we've been able to achieve at this point, we're down to 16 hertz all the way up to 170 kilohertz for the E fields. The mag fields are 16 hertz to 120 kilohertz. Body voltage is 16 to 170 kilohertz. And what we're finding as well too, we're testing other meters as we do this, and we're finding that other meters just simply state they go up this high or higher, and we're not finding that they do, or if they do, I'm just curious about the sensitivity of them at those levels. We're just not seeing it, and we're expecting this to be just not comparable even to other meters that are even out there, unless you look at the gigahertz solution lines, especially the NFA 1000. So the filters we have built in, we're going to have one at 16 hertz, 16.7 for European rail systems. We're going to be able to look at signals above 50 hertz. We're going to be able to look at signals above 60 hertz and signals above 2 kilohertz. So these will be switchable filters that we have inside the meter. and it'll give us more information about whether the majority of the signal is coming from, 60 hertz, the general AC coming off of power lines, or is it high frequency noise, more of the dirty electricity or microsurge electrical pollution in the higher frequency range. So that's what building biologists need to look at, and that we want to give them a good picture of what's going on there. So yeah, again, one axis E fields, it's the Y axis, so that means it's recognizing E fields out the front. 3D mag fields, so X, Y, and Z, as we see here for the mag field levels, and 3-axis body probe or hand probe for body voltage measurements. And the measurement ranges, we're looking at 0.1 millivolt or 0.1 volts per meter to 2000 volts per meter. The mag fields, you can see 0.01 milligauss to around 100. And body voltage 1 millivolt up to about 5,000 millivolts. That gives you a general idea of that. And it does have a max hold, and it'll have an audio Geiger counter ticking sound. So when you move it close to a source, it will give you an indication of, with a ticking sound, whether it's getting stronger or weaker. And again, we're going to make it as accurate as possible, down to 0.5 dBs or better. So it's been in development for 6 months as well. It's been a challenge. We've tried to actually get the 3-dimensional electric fields to work. We understand how to do that now, but the issue is we need a larger enclosure, and we wanted to make one in this enclosure for now. So 3D electric field meter may come in the future. So also future ideas, separate body voltage meter. We're looking at building a basic electric and magnetic field detector somewhere around the $300 mark as well, which we think will fit in nicely. So those are our future ideas and our future plans. And Keith, that wraps it up on my end. So I will stop the share and flip it back over to you.
That sounds great. Thank you very much for that presentation. So
You're very welcome.
Yep. So I want to just kind of pick out a couple of things here, maybe ask you some detailed questions here. For people who are relatively new to this issue of sort of the nexus between human health and electromagnetic fields, this is not the 1 meter to buy if you're going to buy 1 meter, correct?
Correct. Yeah, this is a specialty meter, but on the other hand, I would say what we're learning there's more and more need for it.
Yes.
But yes, checking for electric fields, magnetic fields, and lower frequency RF is the critical points we need to check for at this point, and also the dirty electricity component too. This meter does fit into that, but it would be good to start with those other ones as well. Unless this is your primary concern. If your primary concern would be, am I getting blasted with 5G signals? This is the meter for you then too. So,
yeah, I just wanted to kind of come from a perspective of a lot of times people will have the idea when they're just getting started that it's just about getting a meter. And this is a meter with a particular purpose. In fact, it has a broader frequency range than any meter that I'm aware of. So this is like twice the frequency range of your Safe and Sound Pro, right?
That's correct. Yes.
And at a much higher frequency level. So it's really a specialty item.
Yeah, exactly, Keith. And yeah, the only thing out there on the market now is industry level type of equipment, which ranges, $15,000 to 40, 50. You can spend $100,000 on measuring equipment to measure this at this point. And that's been part of the challenge of identifying all these problems. We're not sure because we just didn't have the proper equipment to go out there and measure it. But, as you found, and we're finding, we're getting some surprises along the way as we use this meter.
And they're really, you talk about the existing equipment. It's very expensive, and I would imagine it's not very portable, not something you'd be able to put in a pocket, for example.
This is true. Yes.
So this is really the first product of its kind that I'm aware of that has this level of sensitivity in this broad A frequency range.
Correct. Yeah, I think even the industry meters out there will have a tough time going down this low, the broadband meters that are out there. Because when you're designing meters, you have only so much of a range you can deal with dynamically or with power. So you can focus on the small signals or you can focus on the big signals. And because it's industry, they tend to focus more on the higher power signals because they're worried about exceeding FCC and Industry Canada guidelines at the high end and designing their equipment so it doesn't violate any transmission laws that are out there. So
Right.
they want to be in compliance. Yeah.
Which is about 1,000 to 1,000,000 times different than what we're interested in looking at. Would you?
Exactly. Yes. So we're focused on more of the lower power signals and trying to eliminate all of them and having a piece of equipment that has a capability of doing that. Yeah.
So we've talked for a long time about this being a 5G meter, and particularly in the high range. And it is certainly that. But you mentioned as well, we're finding other things that are being used in these frequency ranges. So it's more than just 5G, but it certainly is targeted at the 5G. And I guess maybe we could have a little bit of a discussion, not getting too deep, but a little bit of a discussion about 5G, because I think there's a lot of confusion among people. What is 5G? So if there's 5G implemented in the, sub 1 gigahertz range in a particular area, it can be said that they have 5G service. And there are higher frequency range band allocations as well. But those are discernible with a meter like a Safe and Sound Pro 2. And this is a much different meter at a much higher frequency level. Can you talk just briefly about 5G, low band, mid band, high band?
Sure. This has been a challenge for us as well in the industry, just to try and figure out what are they coming out with, and just to try and understand the whole concepts of what they're doing. But it was almost like 5G was a new buzzword, so they threw it out everywhere, and people expected when you heard 5G that you would be getting hit, or they would be using millimeter wave meters or wavelengths to transmit these signals, and that's just really not the case. Probably at this point in time, less than 1% of the signals out there are high band 5G signals. The majority are low band, which is between 600 megahertz and 1 gigahertz, or mid band, which are 1 gigahertz to 6 gigs. So the sub 6 gig band all the way down to 600 megahertz is the primary use of 5G signals that are out there transmitted right now. And they're not achieving the speed that the millimeter waves would give you for data transmission. It's going to be a much lower speed than that, but it's going to be a better speed than the current 4G and 3G that's out there at this point in time. So people are going to see a boost in some speed, especially going to the C band, or 2.5 gig to 3.5 gig, 3.7 gig, somewhere in that range. You're going to see speed increases from that over below 1 gigahertz type of signals. But yeah, very, very hard and confusing because there's 3 bands that they can be in. They're repurposing the other cellular frequencies for the new 5G, which is basically a little bit boosted from 4G LTE. It's an increase of speed of a factor 2 or 3 to 4 or 5 times, whereas the high band 5G, you're going to see 10 to 15 times quicker download speeds. So that kind of summarizes my take on this whole 5G. And I think the industry used it as a buzzword to try and get people to purchase 5G phones. So it's a sales and marketing kind of gimmick, I think. But the truth about 5G is there's multiple bands, and very little in the millimeter band is used at this point in time. But I think that may change over time.
Great. And I think more than enough to be concerned with regard to personal exposure to RF, whether your 5G that you're being served in your local area is in the what we would consider to be lower frequency range, or whether it's in this much higher range that we're talking about. The much higher range is less studied. Would you agree with that?
It's less studied.
Yeah.
Correct. Yeah, we don't. Well, we have a general idea of the health effects at this point, but yeah, definitely more studies need to be done, and I think a lot of it is unknown at this point, like you're saying, Keith, for sure.
How did they achieve the increase in speed on the lower frequency end? Are they must be shortening the pulse width for the
Yeah,
modulation scheme. Yeah.
I don't know the exact answer to that, but it could be they're just transmitting at a higher lower frequency that's riding on that band, or they have better data compression algorithms that are packing the data better to send. Um, so yeah, it could be either one of those methods, but I'm not sure which one, honestly.
So I think about people using this meter, or people who just have a concern about their RF exposures for them and for their families. And I think I try to imagine the questions they're asking themselves. And I think one of the questions is, well, do I have 5G in my area? And so this discussion a little bit, I think, has brought up it's going to be a little bit hard to define that, because is it the 5G that's now operating on frequency allocation that was given a short time ago to 3G? Is it that kind of 5G, or is it the 2.5 gigahertz 5G, or is it the much higher range that we're talking about with this meter?
Yeah, exactly. That's the challenge, and primarily Verizon right now is predominantly transmitting in 5G in the millimeter wave band, as opposed to the other carriers. We tend to see more Verizon towers than others in that range, and they are yeah, what appears on their phone is UW. Um, Ultra wideband.
Right.
Basically, that's what that means. And when you see that, it could mean the 5G um, in the mid band between 1 gig and 6 gig, or it could also mean the high band and the 28 gig that they're transmitting, or 30 or 38 or 39 gig. So that's what the millimeter wave meter will tell us. It'll define that, but looking at your phone, I don't think you can tell which is which. So there's more to learn about that. And one of my colleagues, Orem Miller, his website, Create Healthy Homes, he's got some great articles on that. And you can definitely learn some more there from him. He's dedicated a lot of time to this, and he'll be in some of our review sessions, our public review sessions of this meter too. So yeah, still lots to learn about this, and yeah, there's all these little twists and turns and complications when it comes to understanding this.
Yeah, I read his paper with great interest. There is a lot of fabulous information there. One of the things that surprised me was the sort of frequency being broadcast we thought was going to be at a much lower intensity, and indicating the availability of a 5G high band signal, and that wasn't the case. It was really higher intensity than expected.
That's correct. That was one of the surprises we found recently. Yes. Yeah, the scuttlebutt was that they did not transmit anything or something very low unless they were activated. But yeah, we found the contrary to that already. So we're in learning mode. Yep, trying to figure this stuff out. Yeah.
You mentioned the glass penetrating characteristic. That was a real surprise, and I found that as well in my beta testing.
Yeah, absolutely. We've now seen evidence of this with the meters, and we thought that the house would completely protect you, and if it's a solid building material, it certainly will. And yeah, the windows do appear to let some in. They still have quite a bit of attenuation. I'd say between 70 to 90% attenuation, but we're still seeing readings coming through the windows. What's your experience with the level that's coming through the windows, Keith?
I don't know that I've had enough time with it. I actually went out yesterday to try to set something up, and I was going to align my horn with my camera and then use a field recorder to record the audio and whatnot. And I was getting that set up, and we had a nice rainstorm. So
oh man,
kind of put that off. So we'll see what we're able to find out about that. I have noticed that I can see less of what appears to be the collision avoidance radar on the vehicles with the horn. And that might indicate, because I noticed that you mentioned that the lower frequency signals that may be picked up by the stub antenna are going to be rejected by the horn, right?
It'll cut off. It'll cut off at around 24, where the stub may go down to 18 or 20 with some response. Yeah.
So that might indicate that some of that vehicular radar is a bit lower frequency.
Right, exactly. That's how you troubleshoot. That's how you figure these things out. Exactly. Kind of a process of elimination. Yeah.
So the power overload protection, that's outstanding. I wasn't aware of that feature.
Yeah, no, thanks. And yeah, the power overload is important, and with a lot of high-end RF equipment too. If you're doing lab testing, they want you to have the equipment on to warm up for several minutes, up to half an hour, just to get all the RF chips and all the controlling circuitry up to temperature, because there's a difference between when your meter's cold and when it's warmed up. So we've tried to build that in, the temperature compensation, into the meter as well too, which is a factor. So a lot of these things you would never think of, but once you design a meter and you see differences and changes, you have to take that into account. And so that power compensation, or the power protection, is built in, as well as temperature compensation too.
Great. So in terms of the product design here, you're really targeting a customer who has a unique concern for evaluating this particular frequency range, primarily because of 5G high band deployment, whether that be in a professional situation like a EMF consultant, building biologist, or a prosumer as an individual who just has a concern about understanding whether high band has been, the millimeter wave has been deployed in their area. Is that correct?
That's correct. And we have received a lot of calls just regarding those questions, and same with our fellow building biologists out there. They're concerned about being exposed to these millimeter waves because we don't know the exact health effects yet at this point, and they don't know whether they're being exposed to it. And what we're finding is they're not deployed as widely as the current cellular system. It's primarily in sports arenas and major city downtown areas. It is spreading out through various test cities right now too, and that will increase, but the exposure is not as much as the lower frequency radio frequency waves that we're measuring as well. So it's still good to measure both, even if you're concerned about these 5mm waves, or these 5G millimeter waves. You still need, like we said before, to check the lower frequency RF too. But that is who the meter is designed for, somebody that is concerned with 5G millimeter waves in those two bands, the 28 gig and the 39 gig. It will do the measurements justice and tell you what you're seeing.
And then I think, just to be clear, if people want a yes or no answer to the question, do I have millimeter wave deployment where I live? If they would go to what they suspect to be the the antennas for the 5G system. With this meter, they would be able to see the presence or the non-presence of millimeter wave frequencies, correct?
Absolutely. And even if nobody is using their phone, we're finding that some sort of signal is coming out of the towers, like if you want to call it a beacon signal or something like that. Um, once and that noise is a consistent buzzing noise that will demonstrate at some point in time. And then if we have cell phones being activated at that time, you're gonna hear that buzzing noise. There's gonna be some extra noise on top of that regular buzzing noise, which is the data going back and forth too. So yeah, you will be able to pick up the towers, and you will be able to pick up local cell phones that are connected to the tower as well.
Great, great. So if people who may be listening to this are not in North America and they want to purchase one of your products, how would they do that?
We have an international website that they can purchase from. We ship globally on it. There would be no problem placing an order from any other country um, on our website for shipment. Should be no problem at all.
Okay, great. A question I had a previous life doing some of the localization stuff, and I was just curious how that worked out for people who are not in North America. So that's great. Anybody can get it through your website.
That's right. And there's going to be various deployments around the world. Um, some countries may have a lot of these frequencies deployed, and some may have very little. But I think inevitably it's coming in the future. But now we finally have something to evaluate and to understand our exposure to these signals.
All right. Well, fantastic. Rob, I want to thank you so much for your time here today. And that's an exciting new product that you've brought to the market. And I've enjoyed spending this time with you and getting a little bit more clarity on it's a changing thing with 5G and the millimeter wave, and there's a lot of confusion around it. So thanks for spending some time helping to make that more clear as well.
You're welcome, Keith. My pleasure. And yeah, great spending the time with you too.
All right. Thank you.
Welcome.